mind can tell me, what do you think rotation means as it relates to the Earth? Okay? Zach, what's rotation?
It spins around
Spins around every 3 weeks. Well, it doesn't spin around every 3 weeks. It spins around. What's rotation, Takis?
It is a spin that when it starts on.
It spins. Does anybody remember what the word is? What does it spin on? What does the Earth spin on? Remember?
Its axis.
Its axis, okay? Let's pretend this basketball is the Earth, okay? Pretend there's an imaginary, like, popsicle stick in the middle, or a long pin that goes right through, okay? That is the Earth's axis. That's what it spins on. That is its rotation. So imagine it spinning around like this on its axis, okay? Does it spin on its axis straight up and down?
No.
How's it spin? Like that? It's good. It's called the Earth's tilt. So I'm going to use this one because it's got blue and red, so it's easy to see. Kind of like that. When we talk about revolution, we'll understand why it's tilted, what that matters for. But the things that's important for you to know is that the Earth is tilted when it spins. It spins on its axis, which is an imaginary like stick through the middle, like this. Okay? How long does it take for the Earth to spin around once? Does anybody know that? Ricky?
365 days.
No. Marcos?
24 hours.
24 hours, right. The Earth spins once around like this, on its axis every 24 hours. Okay? So let's pretend, I'm not going to plug this in yet because we don't need it, but let's pretend this is the sun. Okay, that light bulb's on, this is the sun. What do you think, what is the important part to know about Earth spinning around on its axis every 24 hours? Sun's coming here. Okay, let's say Indianapolis is here. We live there. There's the sun spinning around on its axis. What happens every day? Hold on, raise your hand. Kevin?
The sun stays where since it's spinning, it goes on the other side.
Okay, and what does that do? What does that do on the Earth, Raul?
What Kevin said is that when the Earth turns, it leaves one side with light because of the sun, and it leaves the other side with light because the sun's on the
Okay, so if we live right here in Indianapolis, what is happening to us each day as we turn around every 24 hours?
Where it's spinning, the sun's going down.
Night and day. Okay, that's the reason for night and day. It has to do with the Earth's rotation. That's the most important thing to remember about the Earth's rotation. Rotation, revolution is 365 days, Ricky, so you're not like totally off board there. We'll get to that. Rotation, the way I always remember it, I kind of figured out this little rhyme. Rotation, stay in place. Revolution, better get moving. Okay? If that helps you, it's kind of silly, I know, but that's how I remember it sometimes when I was a kid. Revolution, better get moving. Rotation, stay in place. Because it's staying in place on its rotation. It's on its axis. It never moves off its axis. It's rotating on a tilt. And every day it creates day and night because it's either facing the sun or not facing the sun. So when we have daytime, the other side of the world has nighttime. And vice versa. It keeps spinning, okay? That's the most important thing to remember for that. Revolution, better get moving. How long does it take to revolve around the sun? Call Ricky, she knows. 365 days. So, this is rotation. What do I have to do if I wanted to make a revolution of the Earth? That's the sun. Tell me, what do I have to do?
Go around the sun.
Like this? I'm going to walk around the sun. That's what I'm going to do. Okay. What am I still doing while I'm going around the sun? Okay. Every time I move around the sun, how many times does this spin?
24.
That's 24 hours for this to spin once. 365, because every time this goes around the sun, this is the Earth, every time it goes around the sun, that's 1 year. It takes 1 year, 365 days, for the Earth to revolve around the sun. Okay, that's revolution, revolve around the sun. But while that's happening, the Earth is still rotating. Every 24 hours it rotates. 24 hours is a day, so it rotates 365 times. Okay? What's the word for how the Earth goes around the sun? It goes around the sun in its
Axis.
No. Axis.
Orbit.
Raise your hand, Raul. Raise your hand so I can call on you. Raul, what do you got? Orbit. Remember, axis. Got to remember the difference. Rotation, revolution. Rotation, stay in place. Revolution, better get moving. The axis is what the Earth rotates on. Its orbit is what it follows, the path it follows around the sun. So right now, my finger is the Earth's axis. It's rotating on it. Where I'm walking is the Earth's orbit. Okay? What shape is the Earth's orbit? Anybody know?
A circle?
Tatiana? It's an oval, but there's a special word that was in your vocabulary last night. That's the type of oval that is the word we're going to use for the Earth's rotation. Ricky?
Elliptical?
An ellipse. It has an elliptical orbit. An ellipse, kind of like a fancy astronomical word for oval. That's kind of what you know. But when you talk about what? Yeah. When you talk about the planets and the Earth and these kinds of things, you need to use the word ellipse. Okay, you need to use the word ellipse. All right, so the whole time, right now, you can't feel it move, obviously. But the whole time we're sitting here in class, the Earth is moving. It's both spinning on its axis, rotating on its axis, creating day and night every 24 hours. And it's revolving in its orbit around the sun. I don't know if you guys know this or not, but I'm going to see if any of you guys can figure it out. Why doesn't the Earth get off its orbit, fly out into outer space? Why doesn't it get off its orbit and bump into other planets, Marcos?
Because if it did, then each planet would run into each other, breaking it, and then soon it'd just be like millions of rocks just floating in the galaxy.
Well, it's very creative. That's what would happen if it did fly off its orbit. But why doesn't it? The Earth has never, and will never, hopefully, fly off its orbit. So Marcos gave us an answer for what would happen if it did fly off its orbit. But I want to know, why doesn't it fly off its orbit, River?
Because the axes are strong and holds it
Well,
out.
the axis is what it's imaginary. There's no such thing. There's not really a stick that goes through the middle of the Earth. The axis is the imaginary point, as if there were a stick that went through, that it rotates on. But its orbit is about revolution. Remember, axis, rotation, orbit, revolution. Ricky, why doesn't it ever go off that path?
Because space, there's no air, so like the Earth's carrying.
That's not true, but that's a very good guess. That uses knowledge that you already have about space.
There's no gravity in outer space.
Ooh, that is definitely not true, but he did think about a topic that it has something to do with. You're thinking of no gravity in the sense of people on the moon floating away, but there's gravity in a certain way. Gravity is a magic word, Tashawn.
Gravitational push.
Whoa! Tashawn! It's what I said about him this morning, right? Sometimes he's flying in outer space. Tashawn, that's brilliant. Thank you very much. Gravitational pull, actually, not push. Gravitational pull. The sun's gravity, okay? Kind of like you have gravity, so you can't float out. It keeps you on Earth. It pulls you to Earth, okay? It's going to pretend this other ball is the sun. It has gravitational pull on all of the planets. Even the planets that are far away, there's gravitational pull. So they can't just fly away, because as they start to go, it's pulling them. So it pulls them in their orbit. Okay, each planet's orbit is determined by the gravitational pull of it around the sun. We're going to use that as the sun again. So, if this is the Earth and this is Venus, they go around the sun differently, not quite exactly like this, but they never then all of a sudden go, whoa, boom, 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 because they have different gravitational pull. So the sun pulls them in a different way based on their size, based on how far away they are. So they have to follow that path, okay? Because that's the gravity. So they start to drift over here, and the sun's pulling them, and that's the constant struggle. The planet's trying to float away, the sun's pulling them. To us, it just looks like a path. All right? Takis, catch this. Olivia, can you catch it? You think? Kevin, can you catch it? You think you can?
I could.
You know what?
Kevin, you throw it over in the garbage. All right. Takis, I want you to rotate that. I want that to be the Earth, and I want to see the Earth's rotation. Olivia, I want to see the Earth's revolution around the sun from you. That's your Earth. I want to see revolution around the sun.
That means you gotta get up.
Olivia, we